We're going to begin January 2012. Now, the first problem in January 2012 is a statistics problem. And they're looking to take a survey of a certain group, and they want to know certain people's opinions. So if they want to distribute this to 100 students and obtain the most reliable, unbiased answers that have no convenience, that won't be swayed one way or the other, they want to pretty much get a mix of everybody. They're asking, where should they survey? Well, they've got every third, so that's your systematic part, that's your randomness. But now they're looking between the office, people sent to the office, which is not a good thing, people in the library, which are studious, and they're asking how they could improve their yearbook. People that go to the gym, they may be more willing to put more sports into it, or any student arriving at school. This one is going to be your most unbiased, because each one of these is going to be a little bit more biased into what their interest is. Number 2 is asking for the sum. So you have an arithmetic sequence, and you can see in the back that you have a formula for the sum. Now, the problem with this is you need the first 19 terms. You're only given the first 5. Now, you still have to find the difference between them, and that difference we see is 7. We need to know that. This is one formula that is not given to you. Well, this is your sum, but the formula to find your last term is not given to you. This one, where you take the first one, then you do n minus 1 times your difference, and you can find your last term, whatever this happens to be. And we can do this for your 19th term. But you have to remember this formula. This is 19 minus 1 times 7. And your 19th term will be 129. Now you can substitute it into this formula. The problem with this is you actually have to remember those pieces. So here's our 19 terms. And we're taking the first plus the last, which you found, divided by 2. And that, you can put in your calculator, will give you its sum. Now, another way around this, and it's really not going to take you that long, you have 5 of these. Continue to find all 19. You're just adding 7 as you go. So you keep adding 7 all the way through to the 19th one and add them up on your calculator. That would work just as easy if you didn't remember this formula, because that is the one that you have to remember. Write it down on your formula sheet. Which expression, when rounded to 3 decimal places, is equal to negative 1.155? Now, that means you can put these in your calculator. If you're more comfortable, some of these are radians, radian, radian, degrees, degrees. If you're more comfortable working in degrees, convert this. Multiply this by 180 over pi, and this is the secant of 150 degrees. Multiply them and keep them there. And this one too, you got to go into DMS to find your degrees. You're going to have to put your 49 in, go to DMS, get the degree sign, 20, put the minute sign. Now, your secant is 1 over your cosine. Your tangent is good, your sine is good, and your cosecant is 1 over your sine. So as you can see, as soon as you put the first one in, this is the one that actually comes out to be that answer. At number 4, you have a composition of functions. We always start at the right, we resolve this one, and roll it into the left. So this is where your x is. So you're going to take your g of 1/2, and you're going to substitute in 1/2 for x. Use your rule, and you can put it in your calculator as well. Keep, change, flip. This is equal to 2. Take that 2 and do f of 2. Roll it into the f. Wherever you see x, you're going to have to put in 2. So here and here. So it'll give you 8 minus 4, and you're equal to 4. So your composition is equal to 4. And number 5, they give you a scenario about rabbits doubling. The doubling is this 2 right here. This is AB to the X. The B is where it's doubling, halving, whatever it happens to be doing. The X is the time. The A is what you initially start at. They gave you the formula. Now, because it doubles every 60 days, if time is in days, you have to make your time up here t divided by 60, which they did. They want to know what is the value of t when the population is 320. Now, you can absolutely work these all backwards. You can substitute this in and put this in here, 10 times 2 to the 240 divided by 60, put it in your calc, see if it comes out to be 320. No. Then try this one. It actually does work for this one. Or you can solve this using your logs. The only way to bring down an exponent that's a variable is through a log. So you start like this. This exponent only belongs to this 2, not the 10. So I'm going to divide both sides by 10. Let's plug in your 320. Divide both sides by 10. Get 2 by itself. Now you also have a couple of choices. You can bring this one down to a base of 2 so that the bases are the same. Then you can set your exponents equal to each other. And at this point, you can just cross multiply them. Cross multiply, and t is 300. Or, if you wanted to, you can take the log of both sides. Bring down your log. I would work one step at a time. Get rid of log 2. Leave this just as it is. Don't divide this out yet. And you notice you're going to have to multiply by 60. So multiply both sides by 60. So t is whatever this is, and you put it in your calculator, and it will also work out to 300. So you have a number of ways you can solve this. Number 6 is looking for a product. Multiply. If you notice, these are the same terms separated by opposite signs. So therefore, these are your perfect squares. So we can take a shortcut, multiply the first terms. X to the 4th times x to the 4th gives you x squared over 16. A positive times a negative will give you a negative. And 1/3 times 1/3 will give you 1/9. So you're looking at x squared over 16 minus 1/9. And there is your choice 2. Number 7 is asking for which one of these graphs represents the cotangent of x. Because you're y equal, you can put this in your y equals. The cotangent is the reciprocal of the tangent. When you do this, do zoom trig. Let it build you a trig graph. That's 7. And you're going to see that it exactly matches up to this one. This is your cosine curve. You should recognize this one. And this is the opposite of your sine curve. This is your cosecant. You can kind of see your sine come out here. This is your tangent. So that one, number 3, is your cotangent. Number 8, this is one of your identities that you must remember. And that is this one. The cosine squared plus the sine squared of x is equal to 1. This is your Pythagorean identity. It works from this. On your unit circle, this is your y, this is your x. So Pythagorean's theorem says x squared plus y squared equals 1. Well, on your unit circle, the x is the same as your cosine. The y is the same as your sine. So therefore, there's your identity, your Pythagorean identity. You have to remember this one. Here's the sum and product. Again, we see this. So pull out A, B, and C. So your sum is negative B over A. Be careful of your negative 4, a negative of a negative, positive, and reduce this, unless they didn't reduce it there, but they did. Your product, C over A. Negative 12 over 6, and reduce this. So we're looking for a sum of 2/3 and a product of negative 2. What you're going to see is number 2. Be careful because they use negatives, positives. Look at them closely and match them up. Number 10 is another example of our ambiguous case of sine. Sine is the only one that has the ambiguous case because in quadrants 1 and 2, both sine is positive. Now, when you set up your triangle, here's your angle B, here's your side B, and here's 9. Again, you can set up your law of sines, because we're going to look for this guy. And when you find your sine, and you put it in your calculator, when you cross multiply, remember you're getting a sine, and then you're going to have to do second sine and find the angle. You're going to get an angle of 58. Now 58 happens in quadrant 1, or in quadrant 2, 180 minus 58. Now this will give you the other angle. But since you already have a 70, if you take 58 and add your 70, you're okay. You can still squeeze in another angle to add up to 180. But in the obtuse case, 122 plus 70 already gives you 192. That can't happen, and you don't even have your third angle. So you're only going to get one situation, an acute triangle only. Number 11 says when x to the negative 1 plus 1 is divided by x plus 1. Now I would take the negative 1, remember negatives use reciprocals, 1 over x plus 1. Now make everybody a denominator of 1 and find a common denominator, which is x. Multiply every numerator by x. This will get rid of that complex fraction. This x comes out, I'm left with 1. 1 times x, x. X times x squared plus x. Now factor this out, factor out an x, and you can see here this common factor is coming out. The numerator is still left with 1. And there's your answer. When all else fails, you can pick a number for x, such as x is equal to 2, and plug it into that division, and then plug each one into the answer. That will help you out too. Number 12, if the amount of time students spend working any week is normally distributed, there's your bell curve, with a mean of 10 hours and a standard deviation of 2 hours, what is the probability that a student works between 8 and 11 hours? Notice they're looking for percents from your curve. Your mean goes here, there's your plus 1, there's your minus 1. We're going to add 2, 12, we're going to subtract 2. Now notice the 11 is halfway at the 0.5. And your chart in the back on your reference sheet is divided by 0.5s. So you're going to pull these two together which comes out to be 34.1, and this one, which is just this one, which is 19.1, and then you will come out with 53.2%, this answer. Work that graph. If you're given it on your reference sheet, always feel free to use this. The conjugate. The conjugate says take the same term, just change the sign in the middle. So look for the one, not changing the first, not changing anything else, just the sign in the middle. Don't change the orders. So we're looking to change the sign in the middle. That's the conjugate. In number 14, notice they give you the difference of two angles. The cosine of the difference of two angles. You also have that on your reference sheet. So fill in the formula for this. Cosine A, cosine B, plus, make sure you reference your sheet, sine B. Don't assume it's the same sign because the cosines work differently. Now notice, I like to set mine up. Here's my angle A. I have a sine, which is 12 over 13. I need the cosine. I have angle B. I have the cosine. I need the sine. So let's take a look at A. Builds us an angle. This is y over r. Use Pythagorean's theorem and find the missing side. So therefore, the cosine is x over r, 5 over 13. In quadrant 2, your cosine is negative. That's where the negative 3 comes in. This is actually a 4. 3, 4, 5 triangle. So the sine, and it's positive in quadrant 2, is 4 over 5. These are the values that you're going to substitute in. So when you see the cosine of A, find me the cosine of A, and substitute it, 5 over 13. Cosine of B, substitute it out, negative 3 over 5. Sine of A, substitute it out, 12 over 13. And sine of B, 4 over 5. Now you could put that in your calculator, flip it back to a fraction, or simply use your rules of multiplication. Multiply the numerators, the denominators, plus the numerators, the denominators, and then combine like terms. And you get 33 over 65, which is this guy. Okay, number 15 is a sequence, is your binomial expansion. This is your binomial expansion. When you do a binomial expansion, start out with something small, like this. FOIL this out. Notice the terms you get. You always get one more than this part. You also, your first argument here has a decreasing exponent. Your second argument increasing your second term. So now, we apply that to this. We know that this is going to give us 4 terms. 1, 2, 3, 4. And we want the third. We want this guy. So start everybody with a C, just to get it out there. 3C0, 3C1, goes the same pattern. We can stop right here. So we're looking at 3C2. Your first term, 2x to the 4th, has a decreasing exponent. So where this would have been my 3, 2, 1. This is a 1. Your second term, and include the negative sign, has the increasing. 0, 1, 2. This also has to add up to that end, 3. Now resolve this. Put this in your calculator, 3. This is to the 1 power. Any negative squared is positive, and you get 6, x to the 4th, y squared.